We keep in Italy because our next speaker is Giuseppe Buscaino, which is, I think, ready for sharing the screen and talk whatever you want.
Okay, hi to all. And today I'm going to show you a result of a study that was already published at the end of 2020 and is about spatio-temporal distribution and acoustic characterization of the haddock calls in the Arctic fjord. So the haddock is a gravid fish and is a significant species for the fishery industry, and it lives at a depth between 80 and 200 meters. You can see here the distribution of these species. So the Svalbard is just in this part, is the limit of the area of this species, but in any case, in the last years, due to climate change, these species move up to the north. So this fish emits sound. So some study about Casaretto and others in tanks find that mainly males produce sound during patrolling display, which are both territorial and spawning behavior. But in any case, also female juvenile produce sound. The results of this tank study was used to identify the species in the fjord in Norway, and to identify reproduction sites. But in any case, no long-term passive acoustic monitoring was performed until now. So the main aims of this study is to characterize haddock calls in the Arctic environment, to evaluate the spatio-temporal distribution of this species using its calls, and explore correlation between haddock acoustic activity and some external physical factors such as solar elevation and tide, and discuss the use of acoustic data for detecting fish age classes and sex, and also haddock behavior patterns. So this is the study area. We are in the north part of Svalbard, so here, and this is the Kongsfjorden. And the most important thing that we have to say about oceanographic condition, that in the fjord come inside warm water from this current, and this warm water mix with the innermost coldest water coming from ice melting. And so in this fjord we have Atlantic Arctic gradient. So this corresponds to a gradient in the ecosystem condition. So we can find both Atlantic and Arctic species. In any case, due to the climate change in the last decades, many species, Atlantic species, move inside the fjord. So following this gradient, we use three sides for record. So we name it the open, middle, and glacier site. And we use this autonomous recorder from wildlife acoustics. So the coordinate is around 79 north of latitude. So about acoustic data analysis, we used the results of Casaretto studies. So what we find in this is a typical double pulse haddock calls. So what we found is the position of indicated here from 1 to 7. So we used these measurements to calculate the duration of the signals, but also the frequency of the first and of the second pulse, and the interpulse interval, and also amplitude ratio between the first and the second pulse. So in particular, the amplitude ratio is used to infer about the sex of the animals. So the ratio between this amplitude and this is positive for female and is negative for male. So concerning the juvenile, this ratio is around 1. Tide was obtained by this site that in Kongsfjorden, and we use NIP tide. And also we calculate the light in the fjord using the elevation angle of the sun respect to the horizon. So when this elevation angle is negative, we have dark. When it is positive, we have light. In total, we collected about 7,000 hours for the 3 sites with a duty cycle of about 30%. And so we didn't record any sound at the inner part of the fjord, and we recorded a few sound in the middle and many sound in the open side. So you can see the mean number of sound per 30 minutes. And we recorded sound only out of the reproduction season of this species, and from July to October. Concerning the correlation with the tide and solar elevation, you can see here in red the tide, and in the green line is the NIP tide. So and the blue point is the number of calls. So you can see here on the left the spectral analysis just to indicate to detect the periodicity of the calls. And during August, you can see here that we have a peak of the calls that correspond to the tide, to the NIP tide. But during October, this peak shift, and we have a periodicity each day. So you can see here also in this graph, we have the day, the hours of the day. In the dark is in the gray is the dark hours. In the white is light, and you can see the pattern of the abundance of calls that follow the solar elevation. So also for October. So finally, for the population structure, you can see this is a picture from Casaretto paper. So our study is blue and the brown point. The blue is open site, brown is a middle fjord. If you focus your attention to the amplitude ratio, you can see that the open site has a similar value to the juvenile, and the middle site in the fjord, middle in the fjord, is at halfway between female and juvenile. So in conclusion, we can say that haddock are present in the Kongsfjord from July to October and is outside of the spawning period of this species. And the periodicity of acoustic activity of this species follow the most important amplitude oscillation of physical forcing available in the environment. During the August, when we have a permanent light condition, acoustic activity follows the tide. And during September, October, when we have light-dark alternation, the periodicity is just 1 day. So also spatial pattern is different because we have in the middle site a few sound, and also this sound is similar to sound of female, and in the outside site near the sea we have mainly juvenile. This is probably due to the temperature of the fjord. So in the external part we have higher value of temperature. So maybe for this reason we found more sound. And also, what we found that the population is mainly caused by juvenile, and this fjord maybe is used not for reproduction but for feeding. And last thing, passive acoustic monitoring is a valid alternative to other expensive techniques. So we can monitor the new invasive species in this extreme environment like Arctic. And this techniques is also valid out of a period of reproduction of these species. Okay, thank you.
Thank you so much. I don't know if we have any question for the audience. Thank you, Gusi. You were, I mean, so well adjusted to the time. It was great. Let me see if someone wants to answer something. Yeah, I see a hand by Jerome.
Yes, hello, thank you very much. I might have missed it, sorry, because I was distracted at some time. But for the signal analysis, did you consider, because you have a pulse signed and the Fourier analysis might not be totally appropriate, did you consider using wavelet analysis?
No, we didn't consider, but maybe in the future, I'm not very confident with the wavelet.
Okay, thank you.
Any other question? Lucy, I want to ask which are your next plans for the research? Now that you could develop this monitoring for such a difficult place and so on. I don't know if you have particular plans for the future. What would you like to answer now?
Yes, our plan, of course, is to continue our monitoring activity, and so at a very long term, we would like to demonstrate that the acoustic presence of the haddock in the fjord change with the time due to climate change, and maybe I don't know when, and in the future the presence increase following the increasing of temperature. So this is the plan, maybe.
Great, that's a great plan, actually. Jeron, again, I don't know if
if no one, if there are no other questions, just a related question, but are the connection with fisheries activities, or haddock is a lot fished? I don't know, are the connections with fishing activities?
You mean in Svalbard about?
In Svalbard or in other places? I mean, can you see connection, and is it relevant actually to make connection with fishing activities? Or
yes, okay. In Svalbard, it's not possible to fish inside this fjord, but of course there is a connection between. You mean that this connection, if we can monitor the population structure and the flex.
Maybe, or if there could be an effect of fishing activities on haddock population that you could see, listen to it actually. So
maybe I don't know exactly.
Okay.
It's quite difficult.
Yes, I guess so. Thank you.
Thank you so much. Okay.